Welcome back to GateX AIML. So today we'll solve some problems on discrete probability distributions, that is binomial, uniform and Poissons. A radio telescope detects on an average 12 cosmic rays per second. What is the probability that exactly 15 rays are detected in 1 second? So how will you identify which distribution? The average 12 cosmic rays per second. So some time interval is mentioned. So it is nothing but follows the Poisson distribution. So they are given lambda equal to 12 rays per second. Then what is the probability that exactly 15 rays are detected in 1 second? So dimension t equal to 1 second. So that implies lambda t is equal to 12. Exactly 15 rays. So p of x equal to 15. That is equal to e power minus lambda t, that is minus 12 into 12 to the power x is 15 divided by 15 factorial. This comes out to be 0.072. Next, a drone has 10 propellers. Each propeller fails independently with probability 0.1. Okay. Now, 10 propellers are there, fails independently with probability. That means some probability, success failure probability they are given. Independently they are mentioned. So it is binomial distribution. So there are 10 propellers. Probability of be careful what is that your P is. P always doesn't mean success. P means in your question what actually P means. In this I will take P as failure probability, that is 0.1. So Q success will be 0.9. See, it doesn't mean that P means success, Q means fail. You take, then you have to change your formula. See, P means what is that I require, what is that I require to solve, that I consider it as my probability P. Now exactly 2 propellers means P of x equal to 2. This is nothing but 10c2 into 0.1 into to the power 2 into 0.9 to the power n minus 2, that is 8. This comes out to be 0.193. Okay. Next, a gamer plays 20 rounds of guessing game with 4 possible moves per round. Using moves at random, what is the probability of guessing correctly in exactly 5 rounds? How will you identify the distribution? So guessing the game, so some success. So what is the probability of success here? 1 by 4, because with 4 possible moves means one move is given. One move is the correct move. So they're asking exactly 5. So 20 rounds, n is 20 trials, Bernoulli trials. So that means Q will be equal to 3 by 4. Right? Now, what is it you have to find exactly 5? P of x equal to 5. That is 20c 5 into 1 by 4 to the power. So what is 5? 5 into 3 by 4 to the power n minus 5 is 15. So this comes out to be 0.202. Next, a food delivery app receives an average of 5 orders per minute. Something in time interval is Poisson distribution. Lambda equal to 5 per minute. What is the probability that it receives at most 3 orders in a given minute? So given minute. So t is equal to 1 minute. Therefore lambda t will be equal to 5. At most means what? P of x is less than or equal to 3. It will be equal to summation of 0 to 3 your distribution, that is e power minus 5 into 5 power x. So this is x equal to 0 to x equal to 3, that divided by x factorial. To solve this, you will get the answer as 0.265. Just check and verify. Next, a student rolls a fair 50-sided die numbered 1 to 50, what is the probability that the result is divisible by 3 or 5? So this is a hypothetical question. Okay, what is 50-sided die? I'm not sure. Okay, now so we can solve it using uniform distribution, or simply you can solve it using principle of inclusion and exclusion, that is probability of divisible by 3. So how many are divisible by 3? So if you see 3, 6, 9 like that, so I think we will get around 16. So 16 numbers are divisible by 3 and 50 numbers. So similarly divisible by 5 is equal to, so 5, 10, 15, 20 like that. So 10 numbers. Okay. Now divisible by 3 or that is union divisible by 5. This is equal to P of divisible by 3 plus P divisible by 5 minus P of A intersection B divisible by 3 and divisible by 5. I have to find this P divisible by 3 and 5 means what? This divisible by 15, right? 3 and 5 means 15. So there are only 3 numbers, that is 15, 30 and 45. 3 by 2. So substitute here 16 plus 10 minus 3 divided by 50. So this is 23 by 50. Okay. Next. The number of raindrops hitting sensor per square centimeter of glass follows a Poisson distribution. Already they have mentioned with mean 1.8. Okay, they are already saying lambda t is 1.8. Now, what is the probability that no raindrop hits in a square centimeter area? Is P of x equal to 0. No raindrops hits is equal to e power minus 1.8 into 1.8 to the power 0 divided by 0 factorial. So if we calculate this, we will get it as 0.1653. Next, from a box of 100 numbered lottery tickets, 3 are drawn at a random. What is the probability that chosen ticket number lies between 41 to E? This is what they are asking. This is uniform distribution. Why? Out of this 100 lottery tickets, I am choosing one. Each has a probability of 1 by n. What is n here? N is equal to d minus a divided by d plus 1. What is b here? So it is 1 to 100. So b a is equal to 100 minus 1 divided by d is 1 because difference is 1 between two consecutive numbers. 1 plus 1, this is 100, n equal to 100. Your probability is 1 by 100, equiprobable. Now what is they are saying here? You don't get confused with 3 are drawn. Even 3 or any number are drawn. So at a chosen ticket, one ticket I am choosing, what is the probability it lies between these numbers? So to find this value you give it, how will you find it out? You can find by using cumulative distribution or you can just find. So how many numbers are there from starting from some numbers say n dash equal to 1 to n dash equal to some value. What is that n dash value? N dash value 60 is say b dash, 41 is a dash. So b dash minus a dash divided by difference is 1 plus 1. So this is b dash, is b dash 60 minus 41 plus 1. This is equal to 20. So 21 by n. That is nothing but 20 divided by 100 to 0.2. Okay. The only confusing part here is 3. The 3 are drawn or any number are drawn, doesn't matter, right? Because one ticket is chosen. So what is that ticket belongs to this range 41 to 60. Next, a message is broadcast to 8 satellites. Each satellite independently receives a signal with probability 0.25. What is the probability that at least 2 satellites receive it? So it's a binomial distribution, right? N equal to 8. Probability of success, that is it receives signals, is 0.25. Q is equal to 0.75. So at least receive it, okay? They're saying receive it. So this is the success probability. That's what we are chosen as P. If it is failure, then this should be P. Okay, in one more example, we'll explain. So at least 2x is greater than or equal to 2. This is nothing but 1 minus P of x is less than or equal to 1. So now you find out 1 minus summation of x equal to 0 to 1, 8c x 0.25 to the power x into 0.75 to the power 8 minus x. If you solve this, you will get the answer as 0.632. Next, in a DNA sequencing, each of 10,000 bases has 0.005 chance of being read incorrectly. What is the probability that exactly 3 errors occurs? So incorrectly errors. Okay, so that means your P will be this value, binomial distribution 0.0005. Should be very careful. You should treat what is the outcome they are asking, what is the probability they have given. So based on that, you have to choose whether it's a success or a failure probability. That is 0.005 is P or Q in your binomial distribution. That is important. Now, so this is now fairly simple. What is that you have to find? Exactly 3 over P of x equal to 3. That is, so 10,000 P into 0.005 to the power 3 into 0.9995 to the power 10,000 minus 3. So it's a little bit big calculation, but can do it using calculator. 0.140. Next, a library has 10 new books, of which a student is familiar with 6. If 5 books are borrowed at random, what is the probability that the student knows at least 3 of them? See, it sounds it is a binomial distribution, but please check here. A library has 10 new books. If you say n equal to 10, and if he is familiar with 6 books, means probability of familiarity, that is success, is 6 by 10. So he is not familiar is 0.4. If 5 books are borrowed at random, what is the probability that the student knows at least 3 of them? See, you know, this is what you have to find. But what about this 5? So 10, to take it as n, then he borrows 5 books. Whether you should take 10 or 5, that is the question. So this is exactly not exactly binomial distribution. So this is actually follows something called as hyper geometric distribution. This is not part of your syllabus, okay? But to solve this problem, you can approximate it to binomial distribution. The approximations are always possible in your distributions. See, for example, in the real world, if some data you have, okay, that data is perfectly may not follow any of the given distribution, standard distribution like binomial or normal or geometric. Okay, sometimes you may have to get the certain parameters, sometimes you have to approximate them. Means hypergeometric distribution is very close. They belong to the same family of binomial distribution. So with some error, I can approximate them. That is the concept of approximation. It is beyond scope of your syllabus, but suppose many students require, I will definitely make one video on other distributions which actually helps to solve many problems in your exams. So you can just, how will you do? You just approximate it to binomial distribution. So you take n equal to 10 and then approximate, you'll get this answer as 0.683. However, if you solve using exactly geometric distribution, which this problem follows, you will get around answer as 0.73 something. Okay. Next. A robot makes an average 2.5 navigation errors per hour. Something they are given. So this is Poisson's distribution in an interval. So lambda is equal to 2.5 per hour. What is the probability that it makes more than 3 hours in a given hour? T equal to 1 hour. That implies lambda t is equal to 2.5. More than 3 errors. P of x is greater than p. This is 1 minus p of x is less than or equal to 2. To do it, 1 minus summation of x equal to 0 to 2 e power minus 2.5 to 2.5 to the power x divided by x factorial. So you will get the answer as 0.242. Next. A shelf has 15 labeled jars 1 to 15. One jar is selected at random. Find the probability that the chosen label is a prime number. So it follows uniform distribution because 15 label jar, so equiprobable 1 by 15, 1 by 15. But you can solve it in a simple way. So in 1 to 15, how many prime numbers are there? What are prime numbers? Prime numbers means which are divisible by itself and 1 other than 1. So from 1 to 15, 2, 3, 5, 7, 11, right? 13. These are all the prime numbers. They are not divisible by any other numbers other than itself and 1. So they are called prime numbers. So how many are there? 6. So 6 divided by 15 is the answer. This. Next. A cluster contains 7 automobile vehicles. Each vehicle independently malfunctions with probability 0.2. What is the probability that exactly 5 remains functional? See, please observe this question. That's what I told. You know that it follows binomial distribution. Now n is equal to 7 automobiles. Each vehicle independently malfunctions with probability 0.2. Malfunctioning, let us consider it as a success probability P. If it malfunctions, then it is successful, what I am saying. Then Q is equal to 0.8. Now, if you observe the question, what is the probability that exactly 5 remain functional? Now, if I take P as malfunctioned and then solve it using normal binomial, then you get a wrong answer because probability of malfunctioning is this. Actually, what you are saying, according to the question that you are finding, if you directly want to find something like this, okay, what will be the p value and q value here? If I take p equal to 0.2, it is malfunctioning, but you are finding functional, exactly 5 functional. So please observe this carefully. Now actually you have to swap it. So these values, if you take, you will get a wrong answer. So actual p is equal to 0.8. Apply, if you want to apply in your formula, q is equal to 0.2 because I have to find functional probability. Now you apply. So 7 p5 into 0.8 to the power, so x, then 0.2 to 2, right? So this comes out to be 0.275. Next, fish enter a tank following a Poisson process with mean 3 per 2 minutes. Lambda is equal to 3 per 2 minutes. What is the probability that no fish enters in the first minute? So t equal to 1 minute, first minute. So lambda equal to 3 by 2 is 1.5. No fish enters means you have to find p of x equal to 0. This is e power minus 1.5 into 1.5 to the power 0 divided by 0 factorial. This is e power minus 1.5. It has 0.223. Next, a box contains 50 rechargeable batteries. Each has a 2% chance of being defective. What is the probability that exactly one defective battery is found? So this is again binomial distribution. Exactly 1, p of x equal to 1. This is 50 c1 into 2% chance of being defective, and then they are asking defective. So your p will be 0.02, whatever they are given. Okay. So please be careful about these three terms. This value, what is that they are given, and then what is that they are asking. Then Q will be 0.98. This will be 1, will be 49. So this comes out to be 0.3707. Next, the research kit contains 8 experimental resistors with values uniformly spaced from 100 to 180 ohms in steps of 10. What is the expected resistance value? So this is following the uniform distribution. So 100, 110 resistor values till 180, because they're saying in steps of 10 uniformly. D is equal to 10 here. So they're not asking any probability, they're asking what is the expected value of the resistance. P of x is very simple, A plus B by 2. This is A, this is B. 100 plus 180 divided by 2 is equal to 140. Next, a coin is flipped 12 times in a simulation. What is the probability that number of heads is between 4 and 8? This is again binomial distribution. 12 probability of head, that is P is equal to 1 by 2. I want heads, and Q will be equal to 1 by 2. They are asking P of 4 inclusive less than x less than or equal to 8. So how will you find this? This is nothing but summation of x equal to 0, x equal to 4, starting from 4 to x equal to 8, 12c x into 1 by 2 to the power x into 1 by 2 to the power n minus 12 minus x. So if you add this, each probabilities for x equal to 4 to 8, you will get the answer as 0.79. Next, an epidemic study records an average one new case every 4 hours. This is every 4 hours means time interval lambda is Poisson distribution. One new case every 4 hours. Okay. What is the probability that fewer than 2 cases are observed in an 8-hour period? So t equal to 8 hours. Therefore lambda t is equal to 2. Next, what is that you have to find? What is the probability that fewer than 2 means P of fewer means less than 2. This will be equal to P of x is less than or equal to 1. So this is summation of x equal to 0 to x equal to 1 e power minus 2 power x divided by x factorial. So the answer will get it as 0.406. Next, a ticket machine issues numbers from 1 to 30 uniformly at random. What is the variance of the distribution? So it is a uniform distribution, right? 1 to, so 1, 2, 3 to 30. This is A, this is B. Notice the difference D equal to 1. So find variance. Variance equal to what? N square minus 1 B square divided by 12 for a discrete uniform distribution. What is N? N equal to B minus A divided by D plus 1. This is 30. So 30 square minus 1 into 1 divided by 12. This comes out to be 74.92. The variance. Next, a space station has 20 sensors, each with 0.05 probability of generating a false signal. So again binomial distribution, just check this. They are asking again at least sensor generates a false signal. So that means our P will be this generating false signal 0.05 Q equal to 0.95. So we find out at least 1 is equal to 1 minus P of x equal to 0 or less than equal to 0 means same. First starts from 0. So 1 minus 20C 0 into P is 0.05 to the power 0 into 9 pi in power 20. So this comes out to be 0.642. Next. A bias coin is tossed where the probability of landing heads is P. Okay, bias coin. So they are not giving what is the probability of head. They are saying it lies between, it's actually greater than 0 and less than 1. They are saying not equal to 0 or 1. That n represents the number of tosses until the first head appears, including the toss where it appears. Assuming independence, the expected value of n is. Again, it looks like a binomial distribution, but if you try to solve it, you will not get it because they are saying the n represents the number of tosses until the first head appears. So we don't know when to stop. There is n is not given here. That is what you have to find. So this actually follows the geometric distribution. The previously it was hypergeometric. This is geometric distribution. Even using the binomial distribution, you can solve it, but you have to do some approximations and then solve it. So this is standard question. E of the expectation of geometric distribution is 1 by P. This is the answer. It required at the end of this syllabus. I will do some more probability and statistics syllabus. Once you complete, I'll try to make some videos where we include some more distributions which are helpful in solving the problem. Next. The arrivals of trains at a station follow Poisson distribution with mean lambda equal to 7 per hour. Lambda equal to 7 per hour. What is the probability that more than 10 trains arrive in 2-hour interval? T equal to 2 hours. That implies lambda t is 14. More than 10 trains. T of x greater than 10. This is equal to 1 minus T of x is less than or equal to 10. Or 1 minus summation of x equal to 0 to 10 e power minus 14 into 14 to the power x divided by x factorial. In the exam, if the question is big, usually they will not ask you to calculate the final value. Usually they will give the option certain things like this, which one is correct, you have to choose. Okay, it is like summing for 10 times. That is not possible, right? In given 3 hours. So sometimes they give short problems like x equal to 0 to 1, you can do it quickly. If there are more number of terms, then usually they will give options like this, which one of these following option is correct. Even if you calculate this, you will get it as 0.864. This is part A. Part B. What is the mean number of trains expected in 2 hours? So what is the expected value of a Poisson distribution? Is nothing but lambda t only, no? See, whatever the Poisson distribution, the parameter that lambda t is itself the mean. So everywhere you can see average number of trains arriving, average number of buses arriving. So this is nothing but lambda is 7 per hour into expected in 2 hours. So 2. So if they say 1, then it becomes 1 year. You should be only careful about this. So answer is 14. Expected number of trains in 2 hours. So thank you for watching. Please like, subscribe and share. Okay, we'll start with continuous